Hey everyone, today we're doing a worksheet on shapes of graph. We'll discuss all kinds of shapes whose graphs you need to know till year 11. So you must have studied some of these graphs and some of these shapes starting from maybe grade 7th, 8th, 9th, 10th, 11th. So by the end of year 11 you need to know all of these shapes because you're expected to know this in the examination. Alright, so the first kind of graph is graph of a linear equation, and we know the general form of a linear equation is y is equals to mx plus c, where m is the slope and c is the y-intercept. That is where the graph cuts the y-axis. So the most basic kind of graph is the graph of equation y is equals to x, which is simply a graph passing through the coordinate axes like this. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And similarly, when x is minus 1, y is minus 1, and so on. So you don't need to make a table for this. Simply make a line like this, which is cutting at 0, 0, 1, 1, and say 2, 2, and make a straight line joining these points. Okay. For this line, y is equals to x, 2, the original line is being translated 2 units up. So this line goes 2 units up. When it goes 2 units up, it cuts here and here. So this would be the new equation. Similarly, for the equation y is equals to x minus 3, the original line gets translated 3 units down. So it lands here. When it goes 3 units down, it lands here and here. So you simply join minus 3 here and 3 here, and you get the line y is equals to x minus 3. Again, you don't need to make the table for this. You should just know by looking at the equation or by looking at the line that this line is the line for the graph y is equals to x translated 3 units down. So y is equals to x minus 3. Okay, next up is the graph for y is equals to minus x. So just like this initial red graph, this is going to be in the opposite direction. So when x is 1, y is going to be minus 1. When x is 2, y is going to be minus 2. Similarly, when x is minus 1, y is going to be 1. So you make a line like this. And then y is equals to minus x plus 2 is the same blue graph but translated 2 units up. So it cut here and here. So we get a graph cutting 2 and 2. And similarly for minus x minus 3, it's the same blue graph but now it's translated 3 units down. Okay, now we're discussing what is meant by the changing slope of a linear equation. So if the slope is y is equals to, let's say, x, where the slope is 1. If the equation is y is equals to x, the slope is 1. This is what the line looks like discussed in just the previous part. Now, if the slope decreases, if let's say it becomes y is equals to half x, then this line would be less steeper. So it's less steeper here. And if it increases, let's say it becomes y is equals to 3x, that means the slope is increasing, then the line becomes more steeper. So as you increase the slope, the line, this is the minimum slope, which is m is equals to 0. This is the maximum slope, which is the undefined slope. Here the slope is undefined. I'll just write u. And this will be a smaller slope, this will be bigger, this will be bigger, and this will be relatively bigger. So you need to know this trend as well. Okay, then if we have a line y equals 3, it's just going to be a horizontal line passing through y equals 3. Here's y equals 3. And similarly, I've shown y is equals to minus 3 here. So it's going to be a horizontal line passing through y equals minus 3. Y is equals to 0 is the x-axis. So it's this line. Similarly, if I've plotted x is equals to 2, which is going to be a horizontal line passing through x2, which was somewhere here, then x is equals to minus 2 will be a vertical line passing through x minus 2. And similarly, x is equals to 0 is actually the y-axis, vertical line passing through x0. Okay, next we will talk about quadratic graphs. So first thing we need to know is if the quadratic equation is in the form of y is equals to x square, where the coefficient of x square is positive. When the coefficient is positive, the graph is a U-shaped graph, and if it's negative, then it's going to be inverted U-shaped graph. Okay, so here I've plotted the graph for y is equals to x. Here it is. And if I now have to identify that which of these two graphs is the graph of x square and which is the graph of 5x square, then I should know that as the coefficient of x square increases, the graph actually squeezes. It's actually called a horizontal shrink, but that will be touched in detail in A levels. Right now you need to know, as we increase the coefficient of x square, the graph will squeeze. Okay, now this looks like a very complicated figure, but let's break it down. Okay, so the first graph is y is equals to x square. How do I identify this particular graph amongst these 6 graphs? I know that the coefficient of x square is positive, so it's going to be a U-shaped graph. So it's this graph, because this graph touches the origin as well. Okay, next is the graph of y equals x minus 6 whole square. What happens over here is that the graph shifts right 6 places to the right. When it's x minus 6 whole square, what is actually happening is that when you substitute x minus 6 is equals to 0, you get x equals to 6. So this red graph moves 6 units towards the right. So this is the shape of that graph. And then similarly, when it's x plus 5 whole square, y equals x plus 5 whole square, when I try to find the x intercept, when I write x plus 5 equals 0, I get x equals to minus 5. So this is the red graph moving 5 places to the left. So this is the graph of x plus 5 whole square. So if these 3 graphs are given and these 3 equations are given, you need to know which equation belongs to which graph. Okay, now let's discuss the graphs underneath. Okay, now we're discussing the graph of this y equals minus x square plus 2. So since it's y equals minus x square plus 2, we know it's going to be an inverted graph. So it's going to be like this. This was 0, 0. So graph of x square is above the origin. The graph of minus x square is below the origin. And there's then plus 2 being added to this graph as well. This plus 2 will simply take this curve 2 units up. So it's going to land here. That's why this is the graph of y equals minus x square plus 2. Let me mark it in green. So this is the graph of y is equals to minus x square. It's upside down. It's inverted u because it's minus x square, and plus 2 simply moves the graph from here to 2 units up. Alright, now let's discuss the graph of this one. Y equals minus x plus 5 whole square minus 3. Okay, so now what's happening over here? It's the coefficient of x square is negative, right? When we'll expand this equation, we'll get negative x square. So that means it's going to be an inverted graph. Alright, and then how do I find the x intercept? I equate this to 0, which simply gives me x plus 5 is equals to 0, which gives me x equals to minus 5. So that means the graph will be aligned with minus 5 over here. Like since it's x plus 5, the graph is moving 5 places to the left. So the original graph of y is equals to minus x square is an inverted graph like this. So the graph of y is equals to minus x minus 5 whole square is the same graph moving 5 units towards the left. So it was plus 5, sorry. So it will move 5 places to the left. Now there is a minus 3 being added to it. So minus 3 would mean that now bring this graph 3 units down. So it goes 3 units down since it's minus 3. So bring this graph 3 units down, that's why this graph will land here. So the original graph, let's repeat, the original graph is going to be something like this, which is y is equals to minus x square. When I change y is equals to minus x square to minus bracket x minus 5, plus 5 whole square, that means this graph will now move 5 places to the left. So it goes 5 left, and then when I subtract 3 to it, it goes 3 places down. So that's why this graph lands here. And similarly, the graph of y equals minus x minus 6 whole square minus 2, let's trace this graph. Y is equals to minus x square is this. Then when we write y, it should touch the origin, something like this. Then if I am writing x minus 6 whole square, that means this graph has to move 6 units towards the right, so it will land here. Then there's a minus 2 outside, that means it is going 2 units down, so it goes 2 units down. Okay, again, if you're given three graphs and 3 equations, you need to be able to identify which equation belongs to which graph. So let's look at this one first. So it's minus x minus 4 whole square and then minus 1. When we'll expand this, we'll get an expression in terms of x square, which means it's a U-shaped graph, not an inverted U-shaped graph. Then to find y-intercept, let's equate this bracket to 0, which gives us x is equals to minus 4. So the graph will be around x equals minus 4. So U-shaped graph is this graph. It goes over here it goes 4 places to the left, and then we're subtracting 1 from it. So that means it goes 1 unit down. So it becomes a graph like this. So that's how this graph, we know that this equation is the equation for this graph. Alright, now let's discuss the other one. What about this one? Okay, so when I expand this, I will get a negative coefficient of x square. So that means the graph has to be an inverted graph, and then I'll find the 2 x intercepts. When I equate both of these equations to 0, I'm getting x is equals to 2 and x is equals to minus 1. So here's the graph that is in inverted U shape, and its x intercepts are 2 and minus 1. So that's how I know that this graph has this shape. Again, you're not being asked to plot these graphs. You're being asked to identify which equation belongs to which graph. Okay? If you had to plot it, you would be given a table and few values of y's and some missing values of x that you'd have to find using your calculator and then exactly plot this. But this is not what this topic is about. This is about identifying the graphs from the equations or vice versa. Okay, the final equation is this. So similarly, it's first identify whether it's going to be coefficient is going to be x square or minus x square. When we'll expand this, we will get x square. That means it's a U-shaped graph. And then write down its x intercept. So these are 4 and 7. So it's going to be a U-shaped graph cutting at x equals to 4 and x equals to 7. Okay, another final example of quadratic graphs and how to identify the graphs from the given equations, or vice versa. You're given the graph, you need to identify which equation belongs to which graph. Okay, so here the x-intercepts would be minus 9 and minus 4 when we equate these to 0. So minus 9 and minus 4, and it's going to be a U-shaped graph, since when we expand this, the coefficient would be x square. Similarly, for the other two, when we'll expand these two, the coefficients would be x square. So U-shaped graph, here the x values of x would be minus 3 and 2. Hence these y-intercept 2 and minus 3. And similarly for the last one, it's 3 and 8. So that's why the x-intercepts are this 3 here and 8 here. Next, we're discussing cubic graphs. Cubic graphs are S-shaped graphs. The basic equation is y is equals to x cubed, which is an S-shaped graph passing through the origin. Similarly, if I change this to x minus 5 whole cube, if I try to find the x-intercept, I'll have to equate this whole thing to 0, which gives me x equals 5. So the same S-shaped graph is now moving 5 places to the right. So this is where it ends up. And similarly, if the equation is x plus 4 whole cube and then plus 1, this means that the original graph of y is equals to x cube is first moving 4 places to the left, then 1 place up. So this graph first goes 4 places left, so something like this, and then 1 place up. And then the graph of y equals minus x cube is simply the reflection of the graph of yx cube on the y-axis. So x cube graph was something like this. Now it's a reflection of that at the other side of the y-axis. Okay, next up are the graphs of reciprocal function. Reciprocal functions are the functions where the denominator has the variable. For example, the most basic one is y is equals to 1 upon x. Now notice when x is 0, then the value of y will be undefined, because if you write 1 upon 0 in your calculator, you will get math error. So that means there is no defined value of y when x is 0. So there should be a discontinuity in the graph when x is 0, which we see here. There's a discontinuity. You won't find any value of y when x is 0. Then you start plotting the remaining values. So as we decrease the values of x from very large values towards very small values, notice that the graph will, what I meant to say was, as you increase the values of x, the values of y will start to decrease, because 1 over, let's say, 0.00001 would be a very big number, and if I write 1 over a million, that would be a very small value. So as we increase the values of x, the values of y decrease. And similar trend happens when we increase, when we're at the negative x-axis. If we start decreasing the values of x, the values of y will also change in this manner. So you'll get a reflection of the original graph in the third quadrant. Okay, so and notice again there should be a discontinuity in the graph. You're not supposed to join these 2 points. Alright, and this line here is called the asymptote. Now what are asymptotes? Asymptotes are also in your syllabus, so you never know what gets asked. It recently got added in the syllabus. So an asymptote is a line where the distance between the curve and this line approaches 0, but it's not actually equals to 0. So as we increase, as the values of y keep increasing, it will come very close to this line, but it will never touch this line. So that's an asymptote. Similarly, we can see asymptotes here. This is an asymptote. This is an asymptote. So all the y-axis in all these graphs are making the asymptotes. Asymptote is a line where the distance between the line tends to 0, but it is never equals to 0. So these lines will not meet. The curve and the line will never meet. But as one of the variable approaches infinity, like when y is approaching infinity, it's increasing and increasing. It gets very close to this, but it will never be equals to, it will never touch this asymptote. Okay. Similarly, the graph of y equals minus 1 upon x will be here and here. Notice when x would be negative, y will be positive, and when x will be positive, y will be negative. That's why the original graphs simply change quadrants. The shape remains the same, but the quadrants change. Okay, for 1 over x square, when x is positive, y is still positive. When x is negative, y is still positive. That's why both the curves land here. And similarly for minus 1 upon x squared, the y will always be negative no matter x is positive or negative. So it's over here. Okay, next up are exponential graphs. So exponential graphs is when the variable is in the power. So 2 power x. So when x is 0, we get 1. So the graph crosses y-axis at 1, and then as we increase the values of x, the values of y will shoot up. So it will be a graph like this. And similarly, as we decrease the values of x, the value of y would become small. For example, 2 power minus 5 will give a small number. 2 power minus 100 would even give a smaller number. So this graph keeps going down, 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 but it will again never touch the line of the x-axis. It won't touch the x-axis. It's going to get very close to 0, but it won't be equals to 0. So again, this purple line is the asymptote here. Similarly, for if we're plotting the graph for y is equals to 100x, then again at x equals to 0, the graph will be, y will be 1, and then as you increase the values of x, this value will shoot up. And as we go down, this value will, as we decrease the values of x, the value of y will become very close to 0, but it will not be equals to 0. This is a very zoomed out graph. That's why it's appearing like the blue line is touching the x-axis, but it wouldn't. Even if I write 100 power minus, let's say 500, it's going to give me a very small number, very close to 0, but it will not be 0. Okay. Now we discuss trigonometric graph, which are again which have been recently added to the syllabus. The most basic form would be y is equals to sine x. The graph of y is equals to sine x, which would be a graph like this. How would you know? When you substitute x0, you'll get 0. When you substitute x90, you get 1. When you substitute x180, you get 0 again. When we substitute x270, we get a minus 1. And at 360, we get a 0 again. And similarly, this is a symmetric graph. So it's not really a symmetric graph, but it similarly continues towards the negative side. But I honestly don't think this would be part of O-level syllabus, IGCSE syllabus. Let's just consider the right hand side. Okay, so this is the graph of y is equals to sine x. What about the graph of y is equals to 2 sine x? This simply gets stretched. The graph gets stretched along the y-axis. So what was 0 initially is still 0 because 0 times 2 is 0. What was 1 becomes 2. 1 times 2 is 2. 0 times 2 is still 0. Minus 1 times 2 is minus 2. 0 times 0 is still 0. So the graph looks like this for y is equals to 2 sine x. Then there's graph of cos x. Again, we'll just ignore this side of the axis. For cos x, when x is 0, you'll get answer 1. When x is 90, you get 0. When x is 180, you get minus 1. For 270, you will get 0. For 360, you get 1 again. So the graph is like this. Similarly, the graph for y is equals to minus cos x. What will happen now? Let me make that graph as well since it's missing. Y equals minus cos x. Now this simply graph will go upside down. So 1 would become minus 1. 0 would still remain 0 by multiplying with minus 1. Minus 1 multiplied with minus 1 gives 1. 0 multiplied by minus 1 gives 0. And 1 multiplied with minus 1 gives minus 1. So the graph will be a graph like this. This is the graph of y is equals to minus x. What if you're asked to plot the graph of y is equals to minus cos x plus 3, which means this orange graph will simply be translated 3 units up. So every point goes 3 units up. This point, minus 1 goes 3 units up, then 1 goes 3 units up. So every point goes 3 units up, so we get a graph like this. And ignore the third graph. Again, I don't think this would be in IGCSE syllabus. It's in A-level syllabus. Okay. Now we're discussing the final kind of trigonometric function, which is y equals tan x. ignore this side again. Negative x-axis would not be asked in IGCSE. Okay, so for tan x, when x is 0, you would get 0. When x is 45, you would get 1. This is very important. And then when x is 90, you'll get a math error. That means there's no value of tan x when x is 90. Similarly, at 180, you'll get 0. At 270, you'll get undefined, which means there's no value of y when x is 270. So the graph is something like this. The values shoot up or shoot down. Again, the dotted purple lines are the asymptotes, where the distance approaches 0, but it's not 0. It's never equals to 0. Similarly, for minus tan x, what happens is these lines reflect. So now you have a line like this line has gone here, then this line has gone here. They just reflect on along the y-axis. So in fact they just flip, the graphs flip. So that's how you plot the graph of y is equals to minus tan x. The graphs flip. Okay, so now let's do some past papers questions from this topic. Question number 1. Which of the graphs shown below could be the graph of y is equals to x cubed? We know that that's a cubic function, and cubic function is an S-shaped graph. So the graph of y cube is this one, figure 6. So this is the graph for this. Then we have 1 upon x square, which is a reciprocal function. And since it's a reciprocal function, at x equals to 0, we should get a math error in our calculator. So that means there's a discontinuity at x equals to 0. So here's a graph with discontinuity at x equals to 0, and here's a graph with discontinuity at x equals to 0. Notice here that x is being squared, which means y will always be positive. So y will be above the x-axis. So this is the graph for y equals x square. And then there's a linear line, y is equals to x minus 1. So that's simply a rising line with y-intercept minus 1. So that's going to be this line, a rising line, since slope is 1 and c is minus 1. The y-intercept is minus 1. So this is the graph of this equation. Okay, in question number 2, we have to do the same. The first equation is y is equals to x square plus 2. X square is a rising line, so it is a U-shaped graph, and plus 2 means that this U-shaped graph is translating 2 units up. So this is y is equals to x square, and then this is y is equals to x square plus 2. So figure 3 is the graph for equation A. Then we have y is equals to x minus 2 and x plus 1. So like discussed earlier, find the x intercepts. Equate this to 0 and we get x equals to 2 and x equals minus 1. And again it has to be a U-shaped graph, since the coefficient of x square will be positive when we expand these. So we're looking for a U-shaped graph with y-intercepts 2 and minus 1. So this is going to be the graph, because this side it would be 2 and this side would be 1. The right hand side should have more weightage, minus 1. So the answer would be figure 2. Figure 2 here. And in the last one we have y equals 2 minus x square. So the coefficient of x square is negative, which means it's going to be a falling, an inverted U-shaped graph. So that's figure 1 only. Question 3. The diagram A, B, C, D, E, and F are 6 graphs of different functions. Complete the table to identify the correct graph of each function. 1 has been done for you. Okay, so we have to start with this. Y equals 1 minus x upon 3. This is a linear equation where C is 1 and M, the slope, is minus 1 upon 3. So we're looking for a falling line, since the slope is negative 1 upon 3, where C is, the y-intercept is 1. So here's the line with, C is 1 and M is negative. So here's the falling line, whose slope is negative and C is 1. So the answer for this should be A. Okay, then we have 2x square, so it's going to be a U-shaped graph, and since it's 2x square plus 0, so it's going to touch the origin when x is 0, y is 0, so that's going to be figure C. And in the last one we have y equals minus 4 upon x. That's a reciprocal function. That means there needs to be a discontinuity at x is equals to 0, because at x equals to 0 the function would be undefined. So that's either this or this. So which one is it? So it says y equals minus 4 upon x, which means when x is a positive number, then the answer should be negative. And when x is a negative number, answer should be positive, because minus in the numerator and minus in the denominator will cancel out. So here's the graph for this. So the answer would be D. When x is positive, y should be negative, and when x is negative, y should be positive. Okay, question number 4. Again, we have to identify what's the graph for y is equals to 1 minus 2x. This is a linear line whose c is 1, the y-intercept is 1, and slope is negative 2. That means it should be a falling line with y-intercept 1. So this is a falling line whose y-intercept is appearing to be 1, and here's a falling line as well, but this y-intercept would be a negative value. So the answer should be graph A for part A. For part B, it's 1 upon x, which is a reciprocal function, which means there needs to be a discontinuity at x equals to 0. So here's the graph with discontinuity, only graph with discontinuity at x equals to 0. So the answer for part B should be F. Part C is a cubic function plus 1. It is being translated 1 unit up. So we're looking for an S-shaped graph that is cutting at 1, cutting y at 1. So this is the graph. So the answer for the part C is D. Question number 5. The first equation given is this: y is equals to x cubed plus 2. So we're looking for an S-shaped graph that goes 2 units up. So this has to be it. No, it could be this as well. So which S-shaped graph? X cubed looks like this. So it's going to be this. Negative x cubed looks like this. So the answer should be part F. Part F is the answer for equation A. Then it's 2 upon x. 2 upon x is a reciprocal function, which means there needs to be a discontinuity at x is equals to 0. Since when you substitute 2 upon 0 in the calculator, it will give you a math error. So at x equals to 0, there should be a discontinuity, which is in graph D. And then we have y is equals to 2 minus x square. The coefficient of x square is negative. That means it's going to be a graph like this. And then it's y equals minus x square plus 2. So the same graph now goes 2 units up. So it's E. Okay, question 6. The first equation is y equals x cubed 1 plus 1. So x cubed is a graph like this. Move it 1 unit up. So here's the graph of part A. So answer for part A is figure F. For part B, it's x square, which is a U-shaped graph, and that U-shaped graph is going 3 units down. So it's going to be this graph, part C. Then the third one is y is equals to 3 power x, which is an exponential graph. So at x0, the value should be 1, because anything power 0 is 1, and then it gradually increases, suddenly increases, and over here it's going to be a graph like this. So that's figure B. Figure B is the answer for part C. And for part D, it's simply the graph of y equals x square is the graph of this, and for x minus 3 whole square, this graph will be moving 3 units towards the right. So that's figure E. Okay, for part 7, we have to sketch the graph of these functions. Y is equals to fx, where fx is 2x minus 1. So let's find the y-intercept and the x-intercept. First, we know it's a linear equation, so it's going to be a straight line. I can tell that c is minus 1, so c will be somewhere over here, minus 1, right, minus 1 over here, and the slope is 2, which means it's going to be a rising line. And while we're at it, find the x-intercept as well. So when y is 0, this one will go to the other side 1, it will become 1, and 1 upon 2 will become half. So if this is 1, then this is half, and the line will pass like this. It's going to be a line like this. It should be a straight line. So this is 1 and that's half. So this is what the graph sketch will look like. And in part B, it's simply x square plus 1. So it's going to be the graph of x square translated 1 unit up. This is going to be 1. Okay, now in part A, we have to sketch the graph of y is equals to x minus 3. Y is equals to x is a line like this. Minus 3 means the same line goes 3 units down. So write 3 here and 3 here, and this is the line. Goes without saying that you're not supposed to draw this one. Okay, so you make a straight line, mark 3 and 3 over here, and you're good to go. Then we have to sketch the graph y is equals to 1 upon x, which is a reciprocal function. Now when x is very small, y would be very big. So we'll start from here, and then as x increases, the value of y will decrease. Because bigger the value in the denominator, the smaller the answer. Okay, make sure these lines do not touch. It may appear that they're touching, but make sure you don't do that. Okay, and then when x is negative, same will happen over here. So we get a curve like this. So that's the sketch for y is equals to 1 upon x. Okay, now we need to sketch the graph of y is equals to cos x for x is between 0 to 360. So cos 0 is 1. So I make a dot over here. Cos 90 is 0. Cos 180 is minus 1. So a dot at minus 1. The 270 is 0. And cos 360 is 1 again. So I'll get a curve like this. This is the graph for y is equals to cos x. It should be smoother. It's not very smooth. So something like this. Okay, now we have to sketch the graph for y is equals to sin x. Sin x is for when x is 0, sin x is 0. When x is 90, sin x is 1. When x is 180, sin x is 0. When x is 270, sin x is minus 1. And you can find all of these using your calculators. And when sin x is 360, sin x is 0 again. So we get a curve like this. Okay. Part B, describe fully the symmetry of this graph for 0 to 360. So as we can see, it has a rotational symmetry of order 2, and the center of rotational symmetry is this. Rotational symmetry of order 2 means that if I rotate this to 180 degree, I'll again get the same shape. Because this will end up over here and this will end up over here. So it's still the same shape. So the order of rotational symmetry is 2. Because when I gave it this red curve a 360 degree spin about this center 180, 0, then it will make come in this form twice. Once at 180 degree and another once at 360 degree. So that's why the order of rotational symmetry is 2. Okay. For part 1, write this expression in the form of completed square form. So for that, I have x square plus 10x plus 4. The method is that divide this with 2, this coefficient with 2, plus 10 divided by 2 is 5. So I'll write x plus 5 whole square plus k. Now I'll ignore this and I'll write 5 square plus k. 5 square plus k, that's equals to this constant here. So that's equals to 4. So k equals 4. Sorry, that's 14 here, not 4. So 14, k equals 14 minus 25, which gives us minus 11. So k is minus 11. So if I write this again, so my completed square form is k plus 5 whole square minus 11. So I have this in completed square form. Now I have to sketch this. So if I have to sketch this, which means I have to sketch this, and this is obvious now, I can tell the turning point from here. So it's the graph of y is equals to x square, then x plus 5 whole square means the same graph is going 5 units towards the left, and minus 11 means the same graph is going 11 units down now. So it will end up here at minus 11, minus 5. So the turning point will be minus 5 here and minus 11 here. So I'll make a graph here with this turning point. So, and since it's the coefficient of x squared is positive, it's going to be a graph like this. And for some extra information, this is also the y-intercept. So this would be 14. That's just some extra information. You don't necessarily need to plot that. But you need to know the turning point. Again, quickly, how do you find the turning point? Reverse this sign, this becomes minus 5. And retain this sign, this is minus 11. So minus 5 comma minus 11 is the turning point, and make a U-shaped graph over here. Okay, in question number 12, on the diagram, sketch the graph of y is equals to x minus 1 whole square. So it's simply y is equals to x square, and then this is translated 1 unit towards the right. So it's going to be a graph like this. Okay, so if I were just supposed to sketch the graph of the first part, I would have done something like this, and we would have been good to go. But now, since we also have to sketch part B, graph of part B, and then solve this second part, so it's important to know this value here as well. So for that, what we'll do, we'll simply substitute x equals to 0 here, and when x is 0, then y is minus 1 whole square, which is 1. So there we should have 1 over here and 1 over here. So that's how I'll sketch it. So here's 1 and here's 1. So it's going to look like this. Then I have to sketch the graph for this. So again, I'll use x is equals to 0. When x is 0, y is 1. So 1 point will be here. And when y is 0, then this 1 will come to this side. Minus 1 times 2 will be minus 2. So when y is 0, x will be minus 2. So somewhere over here. And now I'll join these 2 points with a straight line. So I have the graph of both part A and part B. Part C, the graphs of this and this intersect at A and B. So here's A, and where is B? B will be somewhere over here. We haven't sketched it, but it's going to be something like this. So this will be B. So we need to find points A and B, and we have to find the lengths of A and B. So that means we need points A and B. A I know is 0, 1 already. What's B? So I will have to use lengthy algebra, and no doubt about that because it's for 7 marks. So now I'll find the points of intersection. So I'll equate both the equations. So I'll write x minus 1 whole square, that's x minus 1 whole square, equals half x plus 1, expand the left hand side, a square minus 2ab plus b square equals half x plus 1. I will take the LCM, so x square minus 2x plus 1 equals x plus 2 upon 2, which gives me 2x square minus 4x plus 2 equals x plus 2, rearranging, and I'm getting 2x square minus 5x equals 0. So now it's pretty easy to solve. I'll take x common. So I'm getting 2x minus 5 equals 0. I'm getting x equals to 0. And I'm getting x equals to 5 upon 2. Which means x is 5 upon 2 here. So 5 upon 2 is actually 2.5. And what's the value of y when x is 5 upon 2, which is 2.5? Simply substitute x 2.5 here or here. So wherever you like, I'll just substitute it in the first one. So that's 2.5 minus 1, then whole square is 2.25. So the other point is 2.25. Y is 2.25. Now we have to find the distance between, find the length of AB. So that means we're using coordinate geometry, and we'll use the formula under root y2 minus y1 whole square plus x2 minus x1 whole square. I'm going to change the marker, it's not very visible. So I'll do 1 minus 2.25 whole square plus 0 minus 2.5 whole square and then whole under root. I'll find this out in my calculator. I'll enter the whole thing in my calculator and I'm getting 2.795. And when we round it off to 3 significant figures, we're getting 2.80. That's the final answer.